OpenStax College Algebra. This video will cover Chapter 1.5, Factoring Polynomials from the OpenStax College Algebra book. You can download this textbook for free at openstax.org. We're going to factor the greatest common factor from a polynomial, factor a trinomial, factor by grouping, factor a perfect square trinomial, factor a difference of squares, factor the sum and difference of cubes, and factor expressions using fractional or negative exponents. In factoring polynomials, we're going to begin with an example. Imagine we're trying to find the area of a lawn so we can determine how much grass seed we need to buy, and that's what we see here in this figure. So if I want to start out by finding the area of the entire region, so this length right here is 6x, and this length right here is 10x. So the area for the whole rectangle is 60x squared. But I want to just find the grass. So the area for the portions that do not require grass needs to be subtracted from the entire region. So I need to subtract out the areas that do not need grass. Now this cutout right here is 4 by 4, so that's 16. So there's 2 plots of 16 square feet, or 32 in total. And then I need to determine what this area is right here. Well, it says here it's 4 high, so this is 4, and this length right here is actually going to be 10x minus 8. Since this length here is 4 and this length here is 4 and this entire length is 10, 8. So this length is 4 times 10x minus 8. So that's going to be 40x minus 4 8s are 32. So the grass area is the total area, 60x squared, minus the cutouts, so minus 32, minus 40x minus 32. So that is 60x squared minus 32 minus 40x plus 32. And of course, these two are going to add up to 0. So that's going to leave me with 60x squared minus 40x. Now I can actually already factor this. I can say that 60x squared minus 40x, what each of these has in common is 20x, and that's going to be 3x minus 2. So if I multiply this out, I get this side. So this is the area of the region that requires grass. When we study fractions, we learned the greatest common factor of two numbers. And you remember that's the largest number that evenly divides into both numbers. So 4 is the greatest common factor, or the GCF, of the numbers 16 and 20. Now if I think about 16, its factors are 2, 4, and 8. If I think about 20, its factors are 2, 4, 5, and 10. So the largest number they have in common is 4, the greatest common factor. In example 1, I want to find the greatest common factor of the expression 6x cubed times y cubed plus 45x squared y squared plus 21xy. So the greatest common factor between the numbers 6, 45, and 21 is 3. The greatest common factor between x cubed, x squared, and x is x. And the greatest common factor between y cubed, y squared, and y is y. And now I've got to determine what is the other expression. So what would I have to multiply 3xy by in order to get 6 y cubed, x cubed, y cubed? So that would be 2x squared, y squared. And if I just check that, right? If I just do a check of that, 3xy times 2x squared y squared would give me 6x cubed y cubed. So that does check out. Next I would need, well, I'm going to need 15 here, and then just xy, and then plus 7. Next we'll talk about factoring a trinomial with a leading coefficient of 1. In other words, something that looks a little bit perhaps like x squared plus 5x plus 6. And you'll notice there's an understood coefficient of 1 there. So we can actually write that as the product of x plus 2 multiplied by x plus 3. That's what we mean by factoring. So trinomials of the form x squared plus bx plus c are going to be able to be written in the form x plus p times x plus q. But of course, pq has to equal c and p plus q equals b. And all that really means is I'm seeking factors of 6 in this example here. So I want factors of 6 that sum to 5. So in this case, I want factors of c that sum to b. In example 2, factoring a trinomial with a leading coefficient of 1. So our trinomial is x squared plus 2x minus 15. So we have a leading coefficient of 1. In this case, b equals positive 2 and c equals a negative 15. We need two factors of negative 15 that sum or add up to positive 2. So 1 and negative 15, they're factors of negative 15, but they do not sum up to positive 2. Negative 1 and positive 15, they give you a negative 15, but they do not sum up to 2. 3 and negative 5, but they sum up to negative 2. So factors of negative 15 that sum up to positive 2 are negative 3 and 5. So that means x squared plus 2x minus 15 can factor as x minus 3 multiplied by x plus 5. So we can actually check this. We could FOIL this out. And if we FOIL this out, we'll get, now this is just a check. So we get x squared. The outer is plus 5x minus 3x minus 15. And this is, in fact, going to give us what we need. So we just did this as a check. Factoring by grouping. Trinomials with leading coefficients other than 1 are a little bit more complicated to factor. And for these trinomials, we can use factoring by grouping. We're going to use an example here. So if we have the trinomial 2x squared plus 5x plus 3, I want to think about the product of 2 and 3. So the product of 2 and 3, of course, is 6. That sum up to the middle term, which is 5. And I'm going to rewrite 5x. I'm going to try and get the same factor, if I possibly can, as 2x squared. So 5x is going to equal 2x plus 3x, because they're the factors of 6 that sum up to 5. So I'm going to rewrite this and regroup it. So I have 2x squared plus 2x plus 3x plus 3, and I'm going to regroup into two different groupings, although this is equal sign is valid, right? This side equals this side. And now what I'm going to do is I'm going to factor out the greatest common factor of the first grouping, which is 2x. And I know it sometimes helps students when I use a different color. So this gives me x plus 1. And then I'm going to factor out the greatest common factor of the second grouping. That's 3. And this will be x plus 1. Now notice, if I multiply 2x by x, I get x squared. 2x by 1, I get 2x. If I multiply 3x, I get 3x. And 3 times 1 is plus 3. Now what I have to do is I factor out the greatest common factor of this expression. So the greatest common factor of this expression is x plus 1, isn't it? So that is going to equal x plus 1, and then I have 2x plus 3. So if I multiply 2x and x, if I FOIL this out, I get this middle expression. But notice how I now have two binomial factors. So if I look at the rule here for factoring by grouping, to factor this trinomial that has the form ax squared plus bx plus c by grouping, I want to find two numbers with the product ac and the sum b, and rewrite and factor by grouping as I've shown you here. In example 3, I want to factor the trinomial by grouping, and the trinomial is 5x squared plus 7x minus 6. So I need to find factors of 5 times negative 6, which is of course 30, and those factors must sum to positive 7. So I could think of factors of 30, and I'll just write them here. So I could have 1 and 30. Well, that's never, negative 1 and 30 isn't going to work. 1 and negative 30 isn't going to work because the sum there is positive 29. The sum here is negative 29. That's no good. What about if I had 2 and 15? Maybe negative 2 and 15. Well, then the sum is 13. What about positive 2 and negative 15? Then the sum is negative 13. So they're not going to work. What about 3 and 10? So if I had minus 3 and positive 10, they are going to sum up to positive 7, and that's the one. So I have to rewrite 7x as, well, I need something that I can factor with 5x squared, so I'm going to put that as 10x subtract 3x. So I'm going to rewrite this. It's going to be 5x squared plus 10x subtract 3x subtract 6. And this is going to be my grouping symbols now. I'll put a little plus sign there and I'll group the negatives together. So now I'm going to factor. In the first grouping, I'm going to factor out 5x. And that's going to leave me with x plus 2, isn't it? In the second grouping, I'm going to factor out negative 3. So that's going to leave me with x plus 2. Now I can check that my grouping here is correct. 5x times x is 5x squared. 5x times 2, so that's plus 10x, so the first grouping is correct. Minus 3x minus 6, so that is correct. So I'm just checking. Now you wouldn't normally do that check, but while you're learning, it's a good idea to make sure you've done it correctly. And now what I have to do is factor out the greatest common factor. So this is x plus 2 and 5x minus 3. Next, we will talk about a perfect square trinomial. So a perfect square trinomial is written as the square of a binomial. So for example, a squared plus 2ab plus b squared actually factors to be a plus b squared. A squared, if I got a minus now, minus 2ab plus b squared, that actually is going to factor to be a minus b all squared. And these are perfect square trinomial. Example 4 asks us to factor 25x squared plus 20x plus 4. So the first thing I do is look at the very first term. 25x squared is actually a perfect square. It's 5x all squared. So that means a in this case equals 5x when I'm looking at my perfect square trinomials formula here. Then I look at the very last term, 4 of course, and that equals 2 squared, so that's also a perfect square, and that means that b equals 2. Okay, now is it true the middle term, 20x, does that equal 2ab? So does that equal 2 times 5x times 2? And yes, it does. So I know this is a perfect square. Therefore, I can write it as a, which is 5x, plus b, which is 2, all squared. Now, if I wanted to, if I felt insecure, I could check. I could FOIL this out. I could say 5x plus 2 multiplied by 5x plus 2. If I FOIL this out, I get 25x squared plus 10x plus 10x plus 4, and that is correct. So I have factored it correctly. Now we'll think about factoring the difference of squares. So in this case, I have a squared minus b squared, and that's going to factor to be a plus b multiplied by a minus b. And let me show you why that's true. So a plus b multiplied by a minus b, I'm going to do the FOIL. So first terms is a squared plus the outer term is minus ab plus the inner term is plus ab, and then the last term minus b squared, because plus b minus b is negative b squared. And it always is the case, these two middle terms will cancel out, and that gives me a squared minus b squared. Now I want you to notice something. This is not a perfect square. It's the difference of squares. In example 5, we want to factor 9x squared minus 25. Now, can I write that in the form of a squared minus b squared? Yeah, that's 3x all squared minus 5 squared. Now, this typically would be a mental step. You'd want to kind of check mentally, is it true that the first term is a perfect square and the second term is a perfect square? So that means I have 3x plus 5 multiplied by 3x minus 5. And of course, if you were really careful, you could check that by FOILing it out, but it does work, it is correct. Finally, we'll consider factoring the sum and difference of cubes, and we'll consider two new special products. In the first one, we have a cubed plus b cubed, and this will factor, you'll always have a plus as the first binomial factor because it's a cubed plus b cubed, and then it will be followed by a negative. So a squared minus ab plus b squared. So this is just a formula to remember. And then if we have a cubed minus b cubed, then I know the first binomial factor will be a minus b because it's a subtract. And then this will be a squared plus ab plus b squared. So sometimes some people use this acronym SOAP to remember the signs when factoring the sum and difference. The first letter of the word relates to the sign. So same opposite, always positive. In other words, if you start with a negative, the trinomial here is positive. I just remember if it's a cubed plus b cubed, it starts with a plus b, then there's a negative. It's always the kind of the opposite here. And here's the two formulas. Let's do an example. In example 6, I'm asked to factor x cubed plus 512. So I need to know what is the cube root of 512. I'm going to use my calculator. So math, I'm going to choose number 4 here and input 512. Let's get out from under that square root symbol, and that's 8. So I see that I could rewrite this as x cubed plus 8 cubed. And so now I can use this formula. I know it's a plus, so the first binomial will be x plus 8, and then there'll be a negative here, so I'll have x squared minus 8 times x plus 8 squared, which is 64. Example 7 asks to factor the difference of cubes. Here I have 8x cubed, subtract 125, and I can write that as the difference of cubes. 2x all cubed equals 8x cubed minus 5 cubed, that's 125. So that is going to be 2x subtract 5, and now in the trinomial part I'm going to have a plus. So that's going to be 2x all squared plus 2x times 5 plus 5 squared. And now I just need to multiply that out. So that's 2x minus 5. And in the trinomial, I'll have 4x squared plus 10x plus 25. Factoring expressions with fractional or negative exponents. Again, we use this greatest common factor idea, or the GCF. So we're looking for the variable or exponent that's common to each term. So the example we have here is 2x to the power 1/4 plus 5x to the power 3/4. And what 1/4 and 3/4 have in common is 1/4. So the GCF is 1/4. So I have to pull out x to the power 1/4. So what do I multiply x to the power 1/4 by in order to get 2x to the power 1/4? Well, that's just 2. And then what do I multiply x to the power 1/4 by in order to get 5x to the 3/4? So here I need 5x and it's to the 2/4, right? 2/4 is 1/2. Because remember, if I have x to the power 1/4 times x to the power 2/4 or 1/2, I add the exponents together and that gives me x to the power 3/4. In example 8, we're going to factor an expression with fractional and negative exponents. So we're going to factor the expression 3x times x plus 2 to the power negative 1/3 plus 4 times x plus 2 to the power 2/3. And I will tell you this, the greatest common factor is going to be x plus 2 to the power negative 1/3. Now we want to think about this carefully. X plus 2 to the power 2/3 is going to equal x plus 2 to the negative 1/3 times x plus 2 to the power 1. Now, we usually don't write down that number 1, do we? But that's going to equal x plus 2 to the negative 1/3 plus 1, because remember, this is going to be the product rule for exponents, and that, of course, will be positive 2/3. So what we have here is, let's pull out the greatest common factor, x plus 2 to the power negative 1/3. And now what we're going to get is 3x. And now we will have 3x plus 4 times x plus 2 to the power 1, which we would normally just think is there, isn't it? So that will be x plus 2 to the power negative 1/3, 3x plus 4x plus 8. And now all I have to do is simplify inside the square bracket. So greatest common factor, x plus 2 all to the power negative 1/3. And then I have 7x plus 8.